While lifting maximal weights is the goal for strength training, the goal for hypertrophy training is to build muscle mass. So when it comes to muscle growth, how heavy should we lift? Should we try to lift the most amount of weight possible, or should we limit load to some extent? In this video, we will try to answer these questions. To answer these questions, we first need to understand the concept of muscle stress. Essentially, we perform resistance training as a means to stress a muscle. This stress then causes a disruption to homeostasis, and the muscle grows in response to the stimulus. Although muscles don't know what exercise we are performing or what load is on the bar, all they experience is tension and stress. What exactly stressing the muscle really means is something that we don't fully understand, but the concept of mechanical tension appears to be the leading theory to explain this. Mechanical tension is simply the idea of muscle fibers contracting against resistance to produce high forces. So this is where load comes into the discussion. The assumption is that lifting heavier loads requires higher forces, increases mechanical tension, and induces greater muscle stress. However, this may not always necessarily be the case. Let's now explore which variables will impact how heavy we lift and how this influences muscle growth. The first variable which will impact load are rep ranges. It is pretty obvious that we can't perform as many reps with a heavier load compared with a lighter load. So, based on the rep ranges we aim to lift in, this will determine the load used to some extent. So, what rep ranges are best for muscle growth? This meta-analysis compiled and analyzed the evidence on the effect of rep ranges on hypertrophy. Studies were grouped and compared in 3 different categories. Light loads defined as lighter than a 15 rep max, moderate loads defined as a 9 to 15 rep max, and heavy loads defined as an 8 rep max or heavier. Importantly, this analysis only included studies which involved training to volitional failure, so that proximity to failure was matched between conditions. And it was found that neither rep range category was inherently superior to the other. So, assuming that we are training close to failure, it appears that hypertrophy can be equally achieved across a large spectrum of different rep ranges. However, this doesn't mean that we can lift in any rep range we like. There are limits as to how heavy is too heavy and how light is too light. First, let's explore where the lower end of the hypertrophy rep range spectrum lies. This was explored in this study, which compared the effects of heavy versus moderate load training on muscle growth. Trainees performed this full body training routine 3 times per week for 8 weeks, with all sets taken to failure. One group performed all sets in the 2 to 4 rep range, while the other group trained in the 8 to 12 rep range. And as we can see, the moderate load group saw superior growth of all muscles measured, shown in the orange, compared with the heavy load group, shown in the blue. So it seems that training with less than around 5 reps per set will probably result in slightly inferior muscle growth compared with 5 or more reps per set. Although this is just an approximation, not necessarily a hard cutoff. Furthermore, it appears that we can also lift with 2 higher rep ranges for maximal muscle growth. This was seen in this study, which explored the effects of training with a range of different loads on muscle growth. Trainees performed bicep curls and leg press 3 times per week for 12 weeks. 4 different groups trained with 4 different loads: 80%, 60%, 40%, and 20% 1RM. It was found that the groups training with 80, 60, and 40% 1RM all saw similar muscle growth of the biceps and quads. However, the group training with 20% 1RM saw significantly less growth compared with the heavier loads. However, we can see that the group training with 20% 1RM were performing around 60 to 70 reps per set on average, so this probably is not very practical anyway. So it seems that training with very high rep ranges may compromise hypertrophy. Training with more than around 30 reps per set is probably too light to maximize muscle growth. So overall, it seems that as long as we are training close to failure, we can lift anywhere within the approximate 5 to 30 rep range and achieve similar muscle growth. In terms of load, this means we probably want to make sure we are lifting with a weight that lands us somewhere within this rep range. If we aren't able to perform at least 5 reps, we probably want to drop the load slightly. And if we can perform more than 30 reps, we probably want to increase load. The next variable that will influence how heavy we lift is technique. Technique encompasses a few different factors, so we will cover each one individually. The first and probably most relevant is strictness. This refers to the degree of involvement from other muscles and joints which aren't the target of the lift. In other words, how much cheating we implement. For most exercises, movement from other muscles and joints, and using momentum, is going to allow us to lift more weight. However, this doesn't necessarily mean that the muscle is actually experiencing more tension and stimulus. This is because we are simply using other muscles to help lift the weight, so it isn't really making the target muscle work any harder. There may be instances where a little movement from other joints could improve the stimulus of the target muscle, but this is probably not advisable in most cases. Rather, using very strict technique is usually going to be just as or even more stimulative for the purposes of muscle growth. So what this means is that we should use a load which allows us to perform the movement with strict technique. If you find that you're using too much body English, so to speak, then you might consider dropping the load so that you can use stricter technique. The next component of lifting technique that will influence the amount of load used is range of motion. This refers to the degree of movement we lift through during each rep. In most cases, training through a larger range of motion will reduce how much weight we can lift, while partial range of motion usually allows us to lift heavier loads. But what is better for hypertrophy, partial or full range of motion? This was explored in this meta-analysis, which compared the effectiveness of full versus partial range of motion training on muscle growth. The overall body of evidence suggests that full range of motion tends to be slightly superior compared with partial range of motion, as shown with this circle being towards the right-hand side of the midline. However, when diving a little deeper, it seems that partial range of motion training may be highly effective in some cases. This subgroup analysis found that full range of motion was superior to partial range when training in the shortened position, but partials in the lengthened position were superior to full range of motion. So it seems that we probably want to either train with full range of motion or implement partials in the lengthened range of the exercise. In terms of load, this may have different implications for different exercises. The portions of the exercise which are hardest and easiest will determine if load should be heavier or lighter. For example, rows and pull-down variations may be used with a full range of motion, which will require lighter loads. Although if you decide to perform lengthened partials, this would allow you to use heavier loads, since this is also the range where you will be strongest in. Although for an exercise like bench press, whether you train with full range of motion or lengthened partials, the load will probably be similar, since the lengthened position is where you will be weakest in the lift. The next technique consideration is tempo. This refers to the speed or duration of each rep. There are two separate factors regarding tempo which will influence what load is used, which we will cover separately. The first is the eccentric tempo used. This refers to how slow you lower the weight with each rep. Generally, a slower eccentric tempo will mean that you can't lift as much load, while a faster eccentric tempo will usually allow us to lift more load. However, what eccentric tempo is best for muscle growth? This research review aimed to answer this question. Based on the body of evidence, it seems that both faster and slower eccentric tempos can be effective for muscle growth, although slightly slower tempos seem to promote greater hypertrophy. This is probably because we still want there to be tension on the muscle when lowering the load. We want the muscle to do the work, not gravity. So as a practical recommendation, controlling the negative of each rep by around 2 to 4 seconds is probably a good place to start. Since we want to somewhat control the eccentric tempo, this means we probably won't be able to lift as much load compared with a faster eccentric tempo. So trainees should adjust the load to that which allows active control of the eccentric portion of the rep. The other consideration regarding lifting tempo is the stretch shortening cycle. This refers to the elastic recoil we experience when transitioning from an eccentric to concentric movement. In other words, from the lowering to lifting phase. If we quickly transition between phases, we are usually able to produce higher forces compared with a slow transition between phases. This will allow us to lift more weight in most cases. However, is the stretch shortening cycle beneficial for muscle growth, or is it better to minimize its involvement? Well, this is something that hasn't been directly studied as far as I am aware, although we can use indirect principles to make an informed assumption. The first thing we can look at is what we just covered, eccentric tempo. As we mentioned, hypertrophy is generally superior when eccentric tempo is moderate to slow. Slower eccentrics will generally reduce the magnitude of the stretch shortening cycle, suggesting that it probably isn't beneficial to involve it for muscle growth. Furthermore, recent evidence suggests that the end range of an exercise where the muscle is more lengthened tends to be particularly effective for muscle growth. For example, this study compared the effects of performing partials at different portions of the exercise. Trainees performed partial rep dumbbell preacher curls for 4 sets of 8 to 10 reps, with each set taken to failure. One arm was trained in the shortened range only, while the other arm was trained through the lengthened range only. It was found that both variations produced great biceps growth, although the lengthened partials were overall superior, shown in the orange, compared with the shortened partials, shown in the blue. So when we utilize the stretch shortening cycle, we are likely reducing active muscle contraction in the most lengthened position. This is because we are relying more on the elastic recoil from the tendons to produce force during this portion of the lift, which is usually where the muscle is in its most lengthened position. And as we mentioned, muscle contraction in the lengthened range seems to be particularly beneficial for hypertrophy training. This provides more rationale to minimize involvement of the stretch shortening cycle if the goal is to maximize muscle growth. So based on indirect evidence, it seems that we probably want to limit involvement of the stretch shortening cycle for hypertrophy training. This will likely limit the amount of load we can lift for any given exercise, although this is going to have a bigger impact on some exercises than others. Generally, pressing and squatting movements are going to be influenced most by the stretch shortening cycle, while pulling and hinging movements will be least affected. And the last technique consideration influencing load is the movement pattern of the exercise. This refers to the motion we move our body through space to perform each lift. While each lift has standard rules that apply, there are slight adjustments that lifters can make to perform the lift slightly differently. And the exact movement pattern we perform the lift with will influence how much load we can lift in most cases. This will vary based on muscle anatomy and the specific biomechanics of the movement. An example of how changing the movement pattern of a lift can influence load can be seen during a back squat. A low bar back squat is usually the most efficient way to lift the most amount of weight. And on the other hand, a heel elevated upright squat with the knees pushed forward is far less efficient in terms of our ability to lift heavy loads. So in this case, we will be able to lift more weight with the low bar squat. However, this doesn't necessarily mean that the hypertrophy stimulus we achieve is better with the low bar technique. Although the low bar squat uses a heavier load, the heel elevated upright variation involves a longer moment arm from the knee joint. This means the knee extensors, aka the quadriceps, need to produce more force compared with a shorter moment arm. So in this case, the tension on the quads is probably equal or potentially greater compared with the low bar squat. So the point is, the specific movement pattern you perform a lift with will influence how much load you can use. Furthermore, the external load is not necessarily indicative of the tension your muscle experiences. The next factor influencing how much load we use is exercise selection. This one is pretty obvious. We are naturally able to lift more or less load depending on the exercise we perform for a single muscle group. Similar to the discussion on movement patterns, this is a result of the anatomy of the muscles involved and the biomechanics of the lift. For example, let's compare a barbell bench press with a cable fly. Both exercises are mostly used to target the chest, but we can lift more load with the bench press. This is because the press involves more muscle groups, such as the triceps, and is lifted through a more efficient path, whereas the fly involves fewer muscles and joints and also has a much larger moment arm with the shoulder joint. However, both exercises can be effective at targeting the pecs despite the differences in load used. Additionally, the load used with the cable fly, and any other machine for that matter, will also depend on the design of that specific piece of equipment. So quite clearly, the exercise you perform will influence how much load can be lifted and shouldn't really be compared between exercises. And like we mentioned, this isn't necessarily representative of the tension experienced by the muscle. And the last factor influencing how much load we train with comes down to differences in anatomy between individuals. There are two primary anatomy categories which will influence load lifted. First is our bone structure. More specifically, we are referring to the relative proportions of our skeleton. The proportions of our limb length, torso length, shoulder width, rib cage size, pelvis shape, etc. will all influence how much load we use for each exercise. Although, like we mentioned, this doesn't necessarily mean that the muscles involved will experience more or less tension. We should just be aware that the load one lifter uses shouldn't necessarily be compared with another lifter for the purposes of hypertrophy training. and the other is the attachment sites of our muscles. This refers to where the muscle tendon attaches to the bone. Humans mostly have similar muscle attachment sites, although just like other characteristics, there is variability between individuals. For example, this study explored the variability in attachment sites on bones of the leg. It was found that muscle attachment sites varied by up to 26 millimeters between subjects, which is around 1 inch. While this doesn't sound like a large difference, it can have a significant influence on strength. If one person has a closer or further muscle attachment site to a joint, it will influence the biomechanics of the lift. In this example, the person whose biceps insert further from the elbow joint has greater leverage for elbow flexion and can probably lift more load, with all else being equal. This is because the line of pull from the biceps means that less internal muscular force is required to move the same external load. So what does all of this mean when it comes to lifting in the gym? Well, first we should understand that it is muscle stress, or mechanical tension, however you want to word it, which influences muscle growth, not the load lifted. In other words, it is the internal load on the muscle which determines hypertrophy adaptations, not the external load. Although this doesn't mean we should completely disregard load for hypertrophy, because we need some external load to induce significant muscle stress. But instead of trying to lift the most weight possible, it is probably better to think of the weight we lift as a byproduct of effective hypertrophy training. The load we lift will be influenced by many variables, such as rep ranges, technique, exercise selection, and anatomical variation. However, unless you are trying to maximize strength, you probably shouldn't manipulate all these variables to lift the most amount of weight possible. Instead, trainees should probably manipulate these variables in a way to maximally stress the target muscle in order to provide the best hypertrophic stimulus possible. And the weight used should simply be a function of these variables. Furthermore, the load we use will likely need to increase over time as we get bigger and stronger. This may be necessary to continue providing a good hypertrophic stimulus. However, we probably shouldn't increase load unnecessarily if it sacrifices the stimulus. Load should only be increased if it can provide a superior stimulus.